Welcome to the deep dive. You've sent us a stack of sources about one of the most exciting and maybe one of the most misleading achievements in medical AI. We're talking about the perfect score.
Right. The one that made all the headlines.
Exactly. We're talking about OpenEvidence, the AI search platform that, in 2025, reportedly aced the United States Medical Licensing Examination, the USMLE, a perfect
Um,
100%.
and that single fact, that 100% is like this flashing neon sign. It just promises infallibility.
Yeah, the end of all diagnostic guesswork.
And that's really the tension we have to explore today. Because scoring 100% on a board exam, I mean, that's a phenomenal achievement. But that exam is mostly about factual recall, foundational knowledge.
It's not the real world.
Not at all. Real medicine, especially when you get into subspecialties, it demands this complex, nuanced, multi-step reasoning. You're solving problems that baffle human experts all the time. So that perfect score, it sets a massive expectation that, well, our sources suggest might be pretty far from reality.
And that is the core mission of this deep dive. We're going to unpack a pilot study that basically ignored the USMLE and put OpenEvidence to, well, the ultimate stress test. They used 100 scenarios from the MedExpert QA dataset.
Which is just this incredibly rigorous collection of questions pulled right from 17 different U.S. medical specialty boards. This is the real expert-level stuff.
And crucially, they didn't just test the basic, quick version of the AI. They compared what we'll call OE, the standard open evidence, to its newer, more intensive model, Deep Consult or DC.
The one that's touted as the PhD-level approach.
So we need to find out if taking more time, digging deeper, actually buys you a reliably correct answer when things get really complicated. We're going to compare the speed, the accuracy, and the stability of these two modes.
All right, let's set the stage.
Let's start with the tool itself, OpenEvidence. It was created in 2023, and it just exploded in popularity. It's backed by major players like the New England Journal of Medicine and JAMA for full text access.
Which is huge.
It is, and it's free for U.S. physicians with an NPI number. As of mid-2025, it already had 400,000 users.
Wow. That's a massive footprint. And a big part of its appeal is that accessibility. You use the quick consult mode, the OE mode, you get a response in seconds. It's built for point-of-care decisions.
Right. Gives you an answer in maybe 5 or 6 citations. It's all about efficiency.
Exactly. But then you have the newer mode, Deep Consult, or DC, which came out in mid-2025. And this is described as an agentic AI system.
Okay, so for listeners who aren't, steeped in AI architecture, what does agentic actually mean in this context?
Right. It means it's not a one-shot query. An agentic AI doesn't just pull a final answer directly. It actually it involves multiple internal reasoning loops.
So it's thinking more.
It's trying to. It might break the question down into subproblems, search the literature for each piece, refine its own search strategy, and then build a comprehensive report. It's designed to mimic a researcher.
But that all takes time.
A lot of time.
So the study had to make sure the test itself was tough enough to actually challenge that researcher AI. Why is MedExpert QA so much harder than the USMLE?
Because its goal is completely different. It's designed to test expert reasoning, not just recall. It's got, over 4,400 questions from 17 specialty boards. But the study authors went even further.
How so?
They filtered the questions to minimize the chance that the AI had already seen them in its training data, so it couldn't just, regurgitate a memorized answer.
They made sure the AI had to think.
Exactly. And they modified the answers. Instead of 4 or 5 multiple choice options, they expanded the list to 10.
Ah, so you can't just guess.
You can't. It drastically reduces the odds and forces the model to use precise, deep reasoning to pick the one correct option from a sea of very plausible-sounding wrong ones. And we know this is a tough test because previous studies showed other LLMs just did terribly on it, with scores between 14% and 46%.
Okay, now that we've set up how rigorous this test is, let's look at the core findings. Given that 100% USMLE score, you, the listener, you're probably bracing for results in the high 80s, maybe 90s.
You'd hope so. You'd hope this tool is nearly flawless.
But what they actually found paints a deeply humbling picture of where AI is right now.
Yeah, the results were strikingly low. They really lined up with how poorly other leading LLMs performed on this dataset. The highest overall accuracy they got was just 41% for Deep Consult DC.
And for the quick mode?
Even lower. Only 34% for the quick consult OE.
Ouch! So an overall average accuracy hovering around 40% for the deep dive mode and just 31% for the quick one.
Right. And while DC was a little better, they measured a small relative improvement. Here's the crucial part. The statistical analysis showed there was no statistically significant difference in accuracy between the two methods.
Wait, say that again? No significant difference.
None. It's a major point. While deep consult might seem a tiny bit better here and there, that improvement wasn't reliable enough to matter by scientific standards. The clinician using DC didn't get a measurable real benefit for all that extra effort.
And it gets worse when you look at how often they agreed with each other.
It does. For both of the human evaluators, OE and DC gave the correct answer at the same time, only 25% of the time.
So 75% of the time they were discordant.
Exactly. That's a huge issue. It means if you ask the system the same complex question using both methods, 3 out of 4 times you get wildly different outputs, and, well, neither of them is very likely to be right. That is actively dangerous in a clinical setting.
That leads us right into the next big thing they tested, repeatability, or, LLM consistency. If you ask the exact same question twice, do you get the same answer?
Consistency is everything for trust. And here, for same answer stability, OE hit 77% consistency, and DC was slightly lower at 72%.
Okay, they also measured something called the kappa statistic. It's getting a little deep into the stats weeds. For the listener, what does a kappa score of, say, 0.7 really tell us?
Think of it as a reliability score. A 1.0 would be perfect agreement every single time. Anything above 0.6 is generally considered substantial agreement. So both models are substantially consistent, but they are very far from perfect.
And how does that stack up against a human expert? Because 77% sounds pretty good until you have a benchmark.
It's a really illuminating comparison. If you look at human pathologists reading routine, common breast biopsies, their agreement is incredibly high, like 89% to 92%.
So the AI is less stable than a human on a typical case.
Correct. But here's the twist. When you ask humans to look at the most challenging, the most nuanced diagnostic issues like defining atypia, human agreement plummets. It often falls to between 43% and 53%. So what we have is an AI that's a bit more stable than 2 human experts arguing over the absolute hardest edge case. But it's still way below the stability you need for reliable, everyday clinical work. It just shows the AI still struggles with deterministic output.
That instability is a problem. But let's talk about the practical costs of trying to get those few extra percentage points with deep consult. It really comes down to speed and depth.
Right.
Let's just ask you, the listener. You're rushing through a busy clinic schedule. Which mode are you going to choose?
Oh, without a doubt, you're choosing OE.
Yeah.
The speed difference is astounding. The average response time for OE was just 13 seconds. That's basically instant.
But DC makes you wait. The average response time there was 259 seconds.
That's about 4.5 minutes.
Which is 18 times longer than the quick method.
And that huge delay comes with this massive flood of sources. OE gives you a nice manageable average of about 5 references.
A deep consult.
DC averaged 34.7 references. And the researchers saw outputs with up to 96 references for a single question. That is 6 times more stuff the clinician now has to go and manually verify.
Okay, but this is the really wild part.
Yes. What's just fascinating here, and this is a key finding, is that while DC gave you way more info and took way more time, there was no statistically significant correlation between the number of references or the time taken and the final accuracy of the answer.
So you're telling me that all that extra time, all that extra effort, and all those dozens of extra references, it bought them almost no measurable, reliable benefit in accuracy.
That's precisely the implication. The AI spent 4.5 minutes generating 96 references, only to be wrong just as often as when it was fast.
So from a practical standpoint, a lot of what DC does is just wasted effort.
It seems so, which gives us some crucial guidance. OE mode might be fine for the clinician in a hurry who just needs to check something based on established guidelines. DC seems more aligned with research, but only if you have tons of time and the expertise to sift through all those sources yourself.
Okay, we know the overall accuracy is low. Let's drill down a bit. Did the AI struggle more with one kind of task than another, like diagnosis versus treatment?
They did break that down. And treatment tasks actually showed the highest accuracy for both modes DC at 47% and OE around 44%.
And the worst.
Basic science, questions about fundamental pathophysiology, the underlying mechanisms. The accuracy there just plummeted to 32% for DC and a pretty awful 23.5% for OE.
So the AI is much worse at fundamental science than it is at creating a treatment plan. That tells you a lot about its training data.
It does, though, to be fair. The researchers noted that even with these differences, the type of task didn't have a statistically significant effect on the overall accuracy.
Hmm.
Basically, the models were just struggling across the board when they were forced to reason.
And what about complexity? Did longer questions strip it up?
Again, no statistically significant effect, but there was this interesting kind of inverse trend. For OE, the quick mode, accuracy actually went up with longer questions. Maybe more context helped it narrow things down. But for DC, the deep consult mode, the opposite happened. Accuracy trended down with longer questions.
Suggesting that maybe all that internal reasoning was getting derailed or confused by the sheer complexity.
It's a possibility. The faster model might have benefited from the extra signal and a long prompt, while the agentic one just got lost in the weeds.
And just quickly, any specific body systems that were the hardest?
The highest accuracy for DC was in the digestive system, at 55%. The lowest were in the skeletal system for OE and the respiratory system for DC. But the authors were really careful to say that those are just trends, because the number of questions for each system was pretty low.
Okay, so if we connect all this back to the bigger picture.
If we step back, these low accuracy scores, especially from a model that aced every student exam,
Mhm.
they just showed this huge, persistent gap between factual recall, which is the USMLE, and true expert clinical reasoning, which is what MedExpert QA tests.
And the repeatability issues we talked about, the instability, that really speaks to an inherent weakness in how these models are built, doesn't it?
It does. It comes directly from the probabilistic nature of LLMs. They're generating outputs based on probabilities, not deterministic rules.
Uh,
And that function is what causes the response variability. It means the output is never, ever guaranteed.
And there was another huge safety flag the study raised, what they called a metacognitive failure.
Yes. And this is crucial for patient safety. The study found that neither model ever said, I don't know the answer.
This is to guess.
It confidently generated an answer even when the correct option wasn't even in the list of choices, what they call the K answer. The AI didn't just get it wrong. It was completely unaware of its own limitations and kept offering confident, incorrect advice.
Which violates the most basic principle of medical safety, know when you need to get a second opinion. So given this risk profile, what is the path forward?
Well, the study strongly emphasizes that standardized human validation has to become the norm. Using dual or even multiple expert raters is critical to ensuring we can trust these systems.
At the end of the day, these tools are adjuncts.
They have to be. They're adjuncts to, not replacements for, clinical judgment and expert oversight. These outputs are data points. They are not directives.
So, to summarize the key takeaway from this deep dive, OpenEvidence proved it's excellent at general medical recall, hence the 100% on the USMLE. But when you put it up against complex expert-level reasoning, its accuracy was low, never reliably getting above 42%.
And the PhD-level deep consult mode, for all its extra time and all its extra references, didn't provide any statistically significant accuracy boost. It's just a poor return on a clinician's time.
And that leads to a final sort of provocative thought for you to consider.
This study showed the models did poorly at basic science, but relatively well at creating treatment plans. So why the difference? It suggests the AI might be better at just synthesizing recent published guidelines for current treatments than it is at generating the fundamental pathophysiological reasoning that you need for true expertise. So if the training data is all about guidelines and not core principles, what does that mean for the AI's ability to handle something genuinely new?